Okay, so let's talk about a quadratic sequence. A quadratic sequence is a sequence with this formula. Tn equals to an squared plus bn plus c. This is the formula for the quadratic sequence. When you're trying to find Tn for the quadratic sequence, we want to find a, b, and c. That is what we want to find. But then there is something you need to understand about the quadratic sequence. It has a constant second difference. Constant second difference. What do we mean by constant second difference? So let's look at the sequence. We have 4, we have 7, we have 11, we have 16. Okay, so we can find the difference by saying 7 minus 4, that's going to be 3, 11 minus 7, that's going to be 4, 16 minus 11, that's going to be 5. We can then continue. Usually when we are doing arithmetic sequence, we just stop here, but we can continue and say 4 minus 3, we have 1, and 5 minus 4, we have 1. So you can see we have a constant second difference in this case. Now we can use these values to find a, b, and c for this sequence. But before we do that, we can find the next two terms of this pattern. We can find those terms. How can we do that? We can first start by extending this and say 1 and 1, right? And then I'm going to say 1 plus 5 to get 6, and then 6 plus 16 to get 22. Okay, again I'm going to say 1 plus 6 to get 7, and then 7 plus 22 to get 29. So these are the next two terms of the pattern. We can also continue doing this to find the other terms. Now I'm going to use these numbers to find a, b, and c. First, to find a, whenever we want to find a, we say 2a is equal to this number, which is going to be 1. So we can divide by 2 and get a equals to half. So we've just seen that a is equal to half. Also, we can find b. We can find b by writing 3a plus b equals to this number, which is 3. Okay, so 3 times a, which is half, plus b equals to 3. Okay, solve for b, and we are going to get that b is equals to 3 over 2. Now for the last part, we can say a plus b plus c equals to this number 4, equals to 4. Therefore a is equal to half, b is equal to 3 over 2, plus c equals to 4, and this is going to be 2 plus c equals to 4, and c is equal to 2. Now I've found all the values. Tn is equal to half n squared plus 3 over 2n plus 2. So what did we do? So when you have a quadratic sequence which has a second difference, when you figure out that this is a quadratic sequence, you first need to say that 2a is equal to this number, and you have to say 3a plus b is equal to this number, and then you have to lastly say a plus b plus c is equal to this number, and solve for those equations. Like first starting by finding a, then using that a to solve this equation, and then using b and a to solve this equation to find these terms. That's how easy it is to do it. Okay, that's how we find Tn. You can use Tn to find term number of certain term values. For example, I can ask a question, which term number has a value of 67? So that's going to be Tn equals to 67, and then my formula for Tn is going to be half n squared plus 3 over 2n plus 2. So I'm going to substitute 67 here and say this is going to be 67 equals to half n squared plus 3 over 2n plus 2. What am I doing? I'm given 67 as a term value, I want the term number. Just as we were doing for arithmetic and geometric, we can therefore calculate n. So the first thing I'm going to do is I'm going to multiply everything by 2. I'm going to get 134 equals to n squared plus 3n plus 4. So 0 equals to n squared plus 3n minus 130. Alright, therefore we can factorize this. If you can factorize, if you can't, you can just use your quadratic formula. So it's going to be 10, 13 plus minus, therefore n is equal to 10 or n is equal to negative 13. And we can see that the number of terms can never be negative, therefore n is equal to 10. This is our answer. So we can conclude that T10 is equal to 67. That's how we solve the quadratic sequence.